For centuries, the stars seemed forever beyond our reach, separated by distances almost impossible to imagine. Then one discovery changed everything. The universe has a speed limit, and light always travels at it. Nothing carrying information has ever been observed outrunning light through empty space. That sounds like the end of interstellar dreams, but surprisingly, it may not be. The secret begins with a simple question. What if the ship never breaks the speed limit? Instead of racing through space, could space itself carry the ship across the stars? This strange idea comes directly from Einstein's theory of gravity, called general relativity. According to the theory, gravity is not an invisible pull, but the bending of space itself. Even light follows those bends, curving whenever space becomes distorted by enormous mass. If gravity can reshape space naturally, could advanced technology reshape it deliberately? In 1994, physicist Miguel Alcubierre proposed a remarkable mathematical possibility. His equations described a bubble of space moving faster than light without breaking Einstein's limit. Inside that bubble, the spacecraft itself would remain perfectly still relative to its surroundings. Space ahead would shrink, while space behind would expand, carrying the bubble forward. The ship would never outrun light locally, because space itself would be doing the traveling. Imagine standing on a moving walkway instead of running across an airport terminal. You move quickly overall, yet your own walking speed never changes very much. The warp drive follows a similar principle, replacing the walkway with distorted space-time. It sounds promising, but an enormous obstacle appears almost immediately. The original calculations required an exotic form of negative energy, unlike anything we can produce. Tiny quantum effects hint that negative energy can briefly exist under special laboratory conditions. However, those effects are unimaginably weaker than what a practical warp drive would demand. Later studies found mathematical refinements that reduce the required energy, but not enough for engineering. Today, no experiment has demonstrated a real warp bubble or faster-than-light propulsion. For now, warp drives remain a scientifically inspired theory, an invitation to keep questioning how far human imagination and science may someday travel.